So we've got a question here where we're given three numbers and we want to know, is it possible for a right triangle to have these three numbers as the length of its sides? So to answer this, we're going to use the converse of the Pythagorean theorem. Remember, that's the one that says if these three numbers fit into that a squared plus b squared equals c squared formula, then the answer is yes. Otherwise, the answer is going to be no. So the first thing we have to do here is figure out which one of these side lengths is going to go into which of the variables. Who gets to be A, B, and C? Now, technically, there are 6 different ways we could do that. I don't know about you, but I'm not super excited about taking those three numbers and plugging them into this equation 6 different times, looking to see if one of them hits the jackpot. Right? And that's okay, because it turns out we don't need to. We can narrow this down. All right, first thing you have to remember about a right triangle is the hypotenuse is always the longest side. So if these three lengths are going to be a right triangle, that 14-inch value, that has to be the hypotenuse, and the hypotenuse is the C in the formula. So I get that one for free. Right? I don't have to worry about the other two possible C values. All right, now again, if you think back to the lecture where we talked about the Pythagorean theorem originally, it doesn't matter who gets to be A and B, because 12 squared plus 5 squared and 5 squared plus 12 squared, that's the same number. Right, so since it doesn't matter, I'm going to just go ahead and let 12 be A and 5 be B for no other reason than that's the order they are in the question. All right, so now it's just turned into an arithmetic problem. And I've written this the way this is commonly written, but I should qualify this just a little bit. I don't know that the left-hand side is equal to the right-hand side here. Right? Really what we're trying to do is we're trying to verify that this is true. So really, to be really technical about it, you should maybe put a question mark over the equal sign. But you can be forgiven if you don't, because a lot of times, a lot of textbooks, it's just written with an equal sign. You just kind of have to know what it is we're trying to do here. All right, so now if we go through the arithmetic, 12 squared is 144, 5 squared is 25, 14 squared is 196. And if we add up those numbers on the left, we get something that is not true. 169 is not equal to 196, which means that those three lengths cannot possibly make a right triangle. So if you'd like the full context, you can click on the upper link here to see the corresponding lecture. And if you'd like to see another example, the link below will take you to another presentation where we're going to talk about how to use the Pythagorean theorem to solve kind of a more practical question. And finally, if you like this example or found it helpful, please don't forget to click on the like button down below.